All right, so this is part 2 of the video on the study guide. So we'll continue on with, I believe this is the second part of number 5. So what we're going to do here is we notice that this is a rose, and we know it's a rose because we have a number right in front of the theta. So what we're going to do is we're going to take 0, pi over 2, pi, 3 pi over 2, and 2 pi, and we can keep going if we wanted to. The next one would be for 5 pi over 2, 6 pi over 2, 7 pi over 2, 8 pi over 2, and so forth if we wanted to keep going. We're not going to need to. So if we had a 6 here or a 5 or something, we might want to go on a little bit longer. So we're going to make our table here for theta and r. And we're going to divide each of these by our n, which is 3. How many? You should know how many rose petals there are in this picture. There are 3 petals because this is an odd number. If it was an even number, we would multiply by 2. So, and then we'd have that number of petals. So we're going to divide this by 3, divide 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 by 3, and so forth. And that'll give us our numbers for theta. So we're going to have 0, pi over 6, pi over 3, and that simplifies to pi over 2, 2 pi over 3, that's 5 pi over 6, and 3 pi over 3 is pi. We can probably keep going if we wanted to 7 pi over 6. Notice by this point you should see the pattern. We're using pi over 6, then pi over 3, then pi over 2. 2 pi over 3, pi over 6, pi. We can use 7 pi over 6, 4 pi over 3, 3 pi over 2, and just keep going around the circle. Okay? Alright, so we're going to plug in 0 in here. We're going to get negative 4 times the cosine of 0. Cosine of 0 is 1, so we're going to have negative 4. Pi over 6. Now with roses, if you use this, you can automatically know that you're going to be in a pattern, that the next one here is going to be 0. Pi over 6 in here is going to end up with pi over 2. After you divided the 3 out, cosine of pi over 2 is 0. Negative 4 is 0. Okay? Then you're going to, if this was negative, then this one's going to be positive 4. Then 0. Then negative 4. Then 0. Then positive 4. Then 0. Then if I kept going, it'd just follow the same pattern. So let's go ahead and graph this. 0 and negative 4. 1, 2, 3. It's going to be right here, okay, because 0 degrees, negative 4. Pi over 6 is here, and we're going to go out to 0, so we're going to go back to the origin. Right? Just like that. Pi over 3 and 4. 1, 2, 3, 4. Okay. Out here, coming back to 0 now. Then 2 pi over 3 is here, negative 4 go down. 1, 2, 3, 4. Back to 0. And then complete it here. Right? So there's our 3 petaled rose. Okay? So just remember there's a pattern involved. And if you can remember the pattern and my little trick of dividing by n, you'll be able to get all your points. Okay, let's look at the next one. Put each of the following in these are parametric. We want to put them in rectangular form. So this should be a t, by the way. This is a typo. That's a t. All right, so what we're going to do is I'm going to subtract 2 over and solve for t, and then plug this into my t here, and I'm going to get x equals y minus 2 squared minus 1. So this is already in rectangular form. This is a parabola. So I'm going to go ahead and graph this parabola. That's going to be y positive 2 and over 1. I'm sorry, negative 1. Okay, so we're right here. And then what I'd like to do for this is I'm just going to pick a y value that's above and below it. So y equals 1. So I'm going to put a 1 in here. 1 minus 2 squared minus 1, which is negative 1 squared minus 1, which is 0. So my x value is going to be 0. So when my y value is 1, my x value is 0 is right here. So I really only have to pick 1. Okay, so because I know that it's the same exact spacing, because this, remember, is a line of symmetry. Okay, and it's going to go like this. Okay, so there's my parabola. Now this, remember, this is a, since it's a cosine and a sine, and these are different, this is going to be an ellipse. All right, and the ellipse is going to be x plus 2 squared over 3 squared is 9 plus y minus 4 squared, 4 squared is 16 equals 1, so this is rectangular form. Now we're going to go negative 2 on the x, up 4 on the y, and that's going to be our center. Then we're going to go up 4, 1, 2, 3, 4, down 4, and then over 3 this way, 1, 2, 3, and then we're going to draw our ellipse. Okay, so then we got those numbers from here. Alright, so last one here, this is a hyperbola, and we know it's a hyperbola because it says secant and tangent. And secant, remember, is secant's with the x, so I know it's going to go left and right here. So my formula is going to be x minus 1 squared over 2 squared, which is 4, minus y plus 4 squared over 25 equals 1. And I'm going to graph that with positive 1 down 4. Okay, so there's my center. And then I'm going to go up 2, right 2, and up 5. Okay, over 2, down 5. Here, this is my asymptote. Okay, it's going to go over like that. My other asymptote's going to go this way. And then I'm going to draw my hyperbola like this. 1, 2. Sorry, I went a little too far there. Okay, so there's my hyperbola. All right, so there are those hyperbolas. Let's go on to the last problem here. I'm going to run out of here. So we're going to create a set of parametric equations that would give a graph to look like a pizza. Well, I got my handy-dandy unit circle here, and I think what I'll do is I'll try to make my pizza the easiest way possible. But let me take my unit circle, and I'm going to overlay it right here. And notice that maybe if we're doing in 8 slices, 1, 2, 3, 4, 5, 6, 7, 8. There's my 8 slices. So if I took a slice out, I'll just take this slice out. Okay, and I have my circle. I'm going to try to draw my circle with the unit circle as best as I can. Okay, so here's my pizza. Okay, here's my pizza. Okay, and with 1 slice out. My t-value is going to go from pi over 4 all the way to 2 pi. So I'm going to say that my t-value is going to be from pi over 4 to 2 pi. And let's go ahead and make this a circle. So x equals, let's give it a radius of, I don't know, 5 maybe. Cosine t, and y equals 5 sine t. And we don't need plus or minus here because it's going to be centered in our middle here. Alright, so when you do that, you're going to want to find, if you really want the picture, you're going to want to find this line segment here. And you're going to want to find this line segment here. And you want to go from 0 to, this looks like 0x. Let's say, so this is one of our equations. Or another equation would be x equals 0. I'm sorry, not x equals 0. X equals t. X equals t. And y equals 0. That'll give us this line right here. And that t is going to be from 0 to 6. And the last thing we want to do, which I'll just let you kind of figure out, is what is the equation of this line segment. And I'll tell you right now that you can figure out what that equation is, knowing that the points that you're going to cross are 0, 0, and root 2 over 2, root 2 over 2. And use your y equals mx plus b to kind of figure that out, and then you can have two equations for that. Okay? All right, so that's it for this one. And if you want to know exactly, I can answer that question if you contact me or see me after school or see me before school. Okay? That's it.